Good afternoon, students. Today's experiment is about manufacturing of gears through gear shaping and gear hobbing process. The objective of today's experiment is to generate helical gear of given module with a gear shaping machine and to produce a spur gear of given module on a gear hobbing machine. The outcome of the experiment is to give you all a hands-on experience of gear cutting on gear shaping and hobbing machine. Okay, now coming to the machine tool required for the gear shaping operation. The picture on the right is that of an HMT make gear shaping machine. The left picture shows a magnified view of the tool and workpiece region. So you can see the tool or the gear cutter that is here. It is having a reciprocating motion about its own axis, while the workpiece is having a circular motion about its axis. This picture shows the tool work arrangement on a gear hobbing machine. In gear hobbing operation, both the tool and the workpiece rotates about its own axis, as seen in this figure. Now I'll play a video in which both these processes are explained in detail.
Hello, good afternoon. Now today we will see how the gear hobbing and gear shaping operations can be carried out. This is a typical gear shaping machine. It is an HMT machine with the variety of AC150. So this is the gear cutters. It is a helical cutters, and that way the oblique cutters, angles and other things are there. And here it is also responsible for cutting these helical gears. Helical gears have special purpose, and here movement is reciprocation of the cutter and movement of the workpiece is rotation. And sometimes the little bit of rotation of the cutter is also given so that the wear and other things are distributed, so that the wear is not confined to the similar positions of all those cutters itself. It is a tungsten carbide cutter and is a typical production machine, very rarely available in academic institutions, in tandem gear shaping and gear hobbing machine, which can be producing all those part of it. The beauty of the gear shaper is that it can manufacture the internal gears as well as the external spar gears, helical gears and non-helical gears, which cannot be done internal gears by gear hobbing machine. The entire implementation of all those tool movements are implemented mechanically. So the gear changing and other part of it, one can see these are the stock of the different kind of gears. These gears are responsible for the different kind of arrangements of all those movements, index movement, because these rotations and other things are very, very important for indexing. And for every definite module of cutting of any gear, definitely associated with the gear cutter very specs. The most important parameter of a gear is gear module. Gear module will determine the mating criteria with the other type of gears. So gear module for the spar cases, it is PCD divided by number of teeth. So according to that, all those things are set, and the typical for the different module, different cutters are associated with, and different cutters will be associated with this cutting. And for the different helix angles also, different cutters will be there. So that oblique part associated with that has to be fixed in the cutter. So once the cutter is there and decided, one can go for mass production. These machine, if one process, he can earn some revenues associated with that. It is a typical production machine, not just a demonstration machine. It can be utilized for cutting actual gears associated with the shaping type of operations. The entire mechanism is slightly complex and complicated. How these from one motor itself, reciprocation and as well as the index rotation of those workpiece is implemented, and it is produced by Hindustan Machine Tool Bangalore. So this is a typical type of machine, and these cutting fluids based on oils are there because huge amount of heat and other things are generated, and these oil is sticking to the surfaces of all those cut gears so that the less amount of wear and tear and other things will take place. So these kind of lubrications and other things are absolutely important, and one can easily find it out how the cutters and other things and gear profiles are cut. It is typical there in IIT ISM Dhanbad, and very few academic institutions in India were having these two production machine in tandem. One is gear shaper and another one is gear hopper. And this is the main configurations of all those gear cutting on a gear shaper. So slightly complex linkages are associated with, this is the basic structures. It is a horizontal line, and along with that the different kind of rotations will take place, and this is nothing but the cutter itself. Cutter is a tungsten carbide, looks slightly yellowish, and tungsten carbide has a very good wear resistant and all those kind of characteristics. So powder metallurgy product, and this is the gear blank, and according to the gear blank will be placed. And gear cutters and other things I have already told you, depending on the fixed module and fixed helical angle that will be set, and on the basis of that these cutting actions and other things will be there. It is, we have shown the external gears, similar the internal gears will be there, and these are the complex mechanisms where through one single rotation from the motors, all those index rotations and these reciprocating action of the gear cutters will be implemented. As the reciprocation of the gear cutters are there, that is why it is called gear shaper. The difference between gear hopper and gear shaper is that where the axis of the cutter and the axis of the workpiece is parallel, where in case of gear hobbing machine it is perpendicular to that. Gear hobbing machine can generate better tip profile, but gear shaping machine generates higher productivity and also the internal gear cutting also. But gear hobbing machine can also produce this spline shaft, which the conventional gear shapers and all those things cannot produce that. Now we will see what is the gear hobbing machine, and here is the diagram for the hobbing machine. So this is a typical schematic diagram of the gear hobbing machine. The difference is that the axis of the hob is perpendicular to the axis of the cutter. All those things are rotating because it is a rolling action, so that is why it is always better to produce in a gear hobbing machine, because of the rolling actions, the external gear profiles, trapezoidal profiles and all those profiles, even in the helix angle and other things, it will be greater. And there are some kind of starts are there in the gear hobs, and gear hobs are also again module specific and the angle of helix specific. So that is why it is a costly affair, but once it is done, the mass production and other things can be implemented, all those things. But it is a totally an example of mechanization. So only the electrical part of it for the driving and other things is implemented mechanically. There is a CNC hobbing machine, there are many flexibilities are there, but that is pretty costly. So here this is also a production machine, and here we can produce all those things with a limited variety, but unfortunately these gear hobbing machine cannot produce these spline shaft. Better varieties of the better models can produce spline shafts where there is no keyway and other things. It is that the shaft is acting as a gear as well as the shaft. So here you can see these cut of all those workpiece, and there is the hob. So typical angle can be set for the different helical angle, but dedicated hobs and other things are used in case of those things. This is also a production machine. This is also a machine of the product of Hindustan Machine Tool Bangalore, and this is responsible for the rolling actions of those cutters against the workpiece, and on the basis of that the typical profiles with the rolling action can be generated. It is also a production machine. If anyone possesses these kind of machines with the limited range of the modules and other things, one can produce and supply to the automobile and other kind of ancillary industries. So typical hob is there, and hob is where starts are there because it is cut, so that entry and other things are there. Typical feature of a hob, and hob is again a powder metallurgy product, and it is made of the tungsten carbide, very hard and very corrosion, very much wear resistance, another part of it, and that is the specialty of the tungsten carbide fob and other things, and they are responsible for, but again it is very much dedicated for mass production or high great lot size of production, and on the basis of that it can produce in one setting many items similar way, and it can supply all those automobiles requiring huge number of the similar kind of gears, maybe helical gears or spar gears or spline shaft. But the problem is that this machine cannot produce internal gears, but gear shaping machine can produce internal gears. So here also lubricant will be there. Lubricants will be there. So here only the axis of the hub is perpendicular to the axis of the workpiece. So that is the different orientation in comparison to the gear setup. So there is some kind of rolling action, and this is the rolling action which is taking place here itself, and it is fed, and according to that the gear hub will be there. It is a spar gear generation, not the helical gear. So typical hubs are there, then helical grooves also can be produced, helical gears also can be produced, and there are for the specific applications different kind of hubs with modules and other things you can produce. So this is the oil-based lubricant. So oil-based lubricants give lot of lubrication so that the friction and coefficient and other things between the workpiece and the job or cutter and other things. Workpiece and the cutter itself is less so that the profiles are smooth and well good quality those things of the gears can be produced at the speed of the and this machine is running for the last 70 years without much trouble. So as it is a production machine, it is a robust machine, one can use it for manufacturing huge number of gears and other part of it, and on the basis of that one can generate large lot size production. If anyone is the possession of this machine, he can earn huge amount of revenue just producing on this machine, all because he got 6 types of gears, 6 types of types of the module, 6 gear hubs that is there, so there are 8 types. But what the hub is ready, the cutting of the gears and other things is very easy. One has to separate, and in one set you can produce many gears, one after another, without any problem associated with the machine. So this is the important is that product, whatever it means, the different determinations which will be given, and the index motion. This index motion depending on the module is fixed, on the basis of that it will be done. Once the module is changed, the index tool and other kind of gear change, the gearbox itself it has to be checked. So some setting is there for the different kind of motions and other part of it, different kind of modules, and different kind of helix. So printing is also possible for the different angles of the helix and the hubs and other part of it, and they are responsible for doing that. Okay, thank you for your questions, listening and hearing of these two very important operation, gear hubbing and gear shaping machine. So many a times the university institutes are not having those two machines, fortunately we have. We can compare all those machines and we can see how the production machines operate in terms of manufacturing of those gears. Gears are very important till that item of mechanization is used in automobiles and all sorts of machines, and these can be manufactured here itself, but it's in gear machining operation. There are some kind of finishing operations and other things are there. Different kind are then going for gear grinding for finishing for high-end gears, and some gears don't require those kind of finishing. But the machining will be done in these type of machines for the production time. In mini machine you can produce gears but one at a time, and that is a very complex and cumbersome procedure. Complex and cumbersome procedure, one cannot get those things very easily, and productivity is less. Here the productivity is great. You don't have to inject at every point of time, and all those things can come out without much hassle. Thank you.